We're going to focus for this Unit 5 lesson on type of reaction, so identifying type of reaction. We're still going to keep practicing writing the equations out and formula, and we're going to learn how to figure out if a double replacement reaction actually occurs. So we're moving forward from our lessons on Monday and Wednesday of this week. So let's start this inking, and I'll go through by doing examples. Alright, so it says tin reacts with chlorine gas to form tin 4 chloride. So tin is written as NS. It's a metal, so I'm going to start using the small letters that denote the type of reaction or the type of element that we're using, whether it's a solid, liquid, gas, or aqueous that we learned in our lessons a week ago. So we have tin. It reacts with chlorine gas. Remember that chlorine is a diatomic element, so it's written as Cl2. It's a gas, so I'm going to write the G. For this unit, it isn't required. I would not mark off on the test if you didn't write the types of state of matter it is in, but in the upcoming units you will be required to do this, and this is why I want to make sure that I practice with you for every lesson through the end of this unit. It's going to form tin 4 chloride. So I'm going to write tin. It's a +4 charge. Chlorine is a -1. So our formula looks this way. It is going to be an aqueous form because the ions dissociate, and we're going to learn more about that, but I'm just going to put the AQ, aqueous, as AQ. We then need to balance the equation. So we have 2 in front of chlorine to make it 4, and it is balanced. From the type of reaction, we can go back to our notes. Sorry, let me go back to the notes we had earlier this week, and we can see if we scroll up that this would be a synthesis reaction. Would be an example of tin, our 1, and our second would be our chlorine gas coming together to form tin 4 chlorine. So I will write that out as synthesis reaction. Synthesis. Remember, we are going to use synthesis, or I'm going to let you shorthand the synthesis for S. You can use S, since we are not using combination, the word combination in honors chemistry. Let's look at another one. Barium hydroxide breaks down. So I've even used the words appropriately for that type of reaction. So barium hydroxide, practicing barium hydroxide, barium, and then hydroxide is OH. OH is -1, but barium is a +2. So I do need to put my parentheses around there and put the 2 on the outside of the parentheses. It breaks down. So we have a large molecule breaking down into barium oxide. So when you write barium oxide, you have a +2, so barium oxide and water. Make sure it's balanced, and in fact it is balanced, so 2 oxygen, 2 hydrogen, and 1 barium. Okay, we're good. If you're looking at this as a large molecule breaking down into 2, again, keep referring back to your notes that we did in class in the beginning of the week. You have one large molecule and it's breaking down into 2. The only option for this one would be decomposition. So I'll write down decomposition. And it keeps sneaking up here on me here. Synthesis. Alright, so I'm going to move down further, and you'll notice that now it's not giving you the products, it's having you figure out the products. So it's saying yields ... Let's figure these out together. We have calcium, which is a metal. It's a solid, so I'm going to put an S for solid. Hydrochloric acid. All right, well, we know how to write hydrochloric acid. We wrote it in Unit 4, and we need to figure out what's happening. First of all, let's try to figure out what type of reaction is. That should definitely help us. We have 1, and then we have 2 atoms put together. So in this case, I would write down you have 2 atoms put together, so AB plus C, or if you like to use it the way we wrote in our notes, we had A plus BC. So if you look back in your notes, you'll notice that this is a single replacement reaction. Single replacement. we can denote a single replacement shorthand as S.R. Decomposition, I'm sorry, you can use a D for decomposition. So single replacement, you will have to refer back to our activity series to see if they're reactive enough, to see if hydrogen gas and calcium can take place and replace each other, and they in fact can. Calcium's a metal. It is a little bit tricky here because we're trying to figure out calcium's a metal. It should take the spot of a metal. Even though hydrogen isn't a metal, it's still considered the first element. So this would replace the hydrogen. So we now need to figure out what my product is going to be. If I'm going to replace this hydrogen, I'm going to have hydrogen by itself plus my calcium chloride. I'm not done here though, because we know hydrogen can't stand alone. It's a diatomic element, so you must write H2. And then you need to write the formula of calcium chloride correctly. Calcium's +2, chlorine's -1, then you get calcium chloride to write like this. When we balance the equation, we need to put a 2 in front of here to balance out the Cl's and the hydrogens. So this then is our reaction for single replacement. I'm going to go further down here because we, in honors chemistry, I told you that we are only going to do complete combustion reactions. So I want to write this out because incomplete combustion reactions are toxic. So I'll go through it with you just so you're aware, but we are always going to burn completely. So if we were to burn incompletely, that means not everything gets used up, meaning not all the oxygen is used up. So it burns. This is what's burning. So it is a combustion reaction. If it's incomplete, it's producing carbon monoxide, like our complete combustions always produce carbon dioxide. And this is a poison gas. So it's going to always produce that water in liquid, here in liquid form. And this is a gas that's forming. This is a gas, this oxygen. And then we need to balance the equation. You can go ahead and balance the equation and check your answers here. It's 8, 6, 7, and 2. All right, so this is an incomplete. Again, I'm going to test you only on complete combustion reactions, but I did want to just show you what happens if it's incomplete. All right, let's go down a little bit further. You'll notice that our number 6 is also ... So you don't know what the products are. Let's figure out what the reaction is. Again, writing it out. Lead nitrate, and it's lead 2 nitrate. So you're going to have to cross down the 2. This -1 gets crossed down and you leave it like this. And how the hydrogen sulfide is written incorrectly, because we all know that that's an acid in its acid form. So hydrogen sulfide, S and the hydrogen. And then it yields, what is the product that it forms when it yields? Well, here we have a large molecule and a large molecule. So you know this is a double replacement reaction. I'll put a DR for shorthand of double replacement reaction. We do need to make sure that our product actually occurs. So let's make this a double replacement reaction. This lead is +2, so I'm going to put the PB, replace it with the H, and put an S. +2, -2 cancels it out. And we're going to write the next product, which we have hydrogen to start, and then we have our NO3, which is a -1, so we can write out this acid as such. We need to balance the equation, so by putting a 2 here, it is a balanced equation. We do need to see if this actually occurs, so let's take a look at our solubility chart. Lead sulfide. Let's go down a little bit further. And we are specifically going over lead 2, and then we look up sulfide, and if we bring lead 2 and we have sulfide, let me ink here, lead 2 and sulfide, shows an insoluble product. So with that insoluble product, I'm going to box it in. Of course it's jumping around, I apologize. It doesn't like me inking too much. So I'm going to put that, I'm going to put insoluble. That means a solid form. So if you had these two chemicals and you put them into, let's say, a test tube, you would actually see a solid forming. And what that happens when you see a soluble with something that is insoluble, when you see something insoluble within a solution, it looks kind of snotty looking, literally like snots, until you dry it out, and then it would form a solid. And that's what insoluble means. It's forming a solid. So this reaction actually occurs. If one is insoluble, the reaction does occur. If both of these products happen to be soluble, that means that they dissolve. They're just left as their ion form. In the beaker, they would be left as their ion form. No solid is formed. And if there's no solid form, no reaction can occur. And we would write no reaction for that. All right, I do want to do one more of those double replacement reactions, so let's go further down to number 10. Aluminum sulfate, let's write out the aluminum sulfate. And that's +3, -2, so I'll write out the correct formula. And then calcium hydroxide. Calcium is a +2. Hydroxide's -1, so I'll look like this. And it becomes, notice I'm using different words to denote the arrow. Regardless, though, we have an A and a B plus a C and a D. So if we're swapping, it would end up with an A and a D plus a C and a B. That might help you to know how to predict the product. So I'm going to write my aluminum, and I'm going to write my hydroxide. Remember, you're writing the new formula with aluminum hydroxide. Aluminum's +3, hydroxide's -1, so that's the new formula. My plus sign, don't forget. Then we have our C, which is our metal, calcium, and we have sulfate. Both are then +2, -2, so nothing needs to be crisscrossed there. I then need to go through and make sure I have everything balanced. My hydroxide, I need to put a 3 here. Calcium then would put a 3 here to be calcium. Sulfate's 3 on both sides. The only thing I'm forgetting is my 2 on aluminum, I believe. I am now balanced. This is a double replacement reaction, and we know this because, well, we're using two big molecules. So we need to make sure that one of these are, in fact, insoluble. Otherwise, this reaction didn't occur. These products don't even exist. They only exist on paper and not in real life. So let's look up aluminum hydroxide first. Aluminum hydroxide so happens to be insoluble. So if it's insoluble, what we're going to get in the habit of doing is, I'll ink that, insoluble, we're going to box it in, and without jumping around in my inking, I'm going to write the word I. That means the solid has formed. Well, let's just take a look at calcium sulfate just on the chart to see what would happen. Calcium and sulfate also happen to be an insoluble, which doesn't normally occur that we would have two soluble or two insoluble products to form. This is not very typical for that to happen. But in this reaction that keeps jumping around here, let's ink it without it jumping around, we could put the insoluble. Okay. So because I wrote the example and we've got it with both insolubles, we'll do this. However, for most of the reactions that occur in lab, the ones that we do, we'll have at least one insoluble. That means the reaction occurred. If both of them, both are soluble, then no reaction occurs. Okay, so we write no reaction. But because they're insoluble, that means not soluble, that means they're not left in the ion form, and we have a solid, so the reaction does occur.